So here are the second midterm review slides. These have been uploaded on Piazza under lecture slides, and some resources are also uploaded under general resources. We have the next class Thursday, July 30th as the exam 2 date. Now, in terms of logistics, I'm going to assume that the same time slot that you guys signed up for exam 1 is good for all students. I'm going to make that assumption. If you have forgotten the time slot that you have signed up for, please refer to your Gradescope submission, and that was titled exam 1 time slot sign up. So just refer to that submission, and actually the score that you got for that submission, 1 or 2, was the time slot that you signed up for, 1 or 2. If you would like to change your time slot between now and the exam time, please send me an email before Tuesday, July 28th, 11:59 p.m. Eastern, so that I can send you the appropriate WebEx meeting invitation. So make a note of that date, and if you need to change your time slot, send me that email. Time slot 1 is between 10:30 and 12:30 p.m. So we have a 2-hour exam, just like last time. Time slot 2 is between 9 and 11 p.m. the same day. 2-hour exam, out of which 20 minutes are recommended to upload and scan and upload your exam. Exam 2 will be made available using the file transfer option just in your WebEx meeting, just as we did in the previous exam. Links to those WebEx meetings will be emailed on Wednesday evening, before Wednesday evening. So please do not go to the class link. This link is not going to be useful. Nobody's going to be here, hopefully. I'm going to make 2 new meetings, one for the time slot 1, one for time slot 2, and that particular email will be sent out. So use those WebEx meeting links instead. Now, just like last time, I'm recommending some Gradescope uploading times. Last 20 minutes of each time slot for scanning and uploading. And while you upload, make sure you map the pages to the problem numbers. And my recommendation will be the same, 1 problem per page, in order for that uploading process to go smoother and faster. After you submit, please go back and check that your submission went through okay. Note that Gradescope submission will close at due time, so try to get it in before the close of that submission. Questions here? All right, let's move on. What is allowed during this exam? Similar things as exam 1. Hard copy books and notes are allowed. You should have the Fourier Transform and Fourier series tables document from Piazza handy. You will need it definitely during the exam, so make sure you have that with you. Writing supplies. You will be using your laptop or desktop only to view the exam questions, type in private clarification questions to me, and for proctoring purposes. What is not allowed during the exam? Calculators, iPads, tablets, phones, headphones, earphones, any other electronic device. Make sure that you do not have headphones or earphones on during the exam. Some of you were doing this in exam 1, and I asked you to stop it. Hope I'm just trying to remind you that that is not allowed during the exam. Okay, questions about this? You're again writing things on paper and uploading. please do not use electronic means like touchscreen, iPad, tablet to answer the questions. Okay, let's move on. For proctoring, you will be required to join the WebEx meeting that you have signed up for 15 minutes before the start of exam. This is a strict requirement. Join ahead of time so that we can all get set up. Links to join will be emailed directly to the students based on the time slot you have signed up for. Expect this email before Wednesday 6 p.m. Eastern. You will be asked to keep your camera and microphone turned on the entire duration of the exam. You will be asked to turn off your computer volume. So you're not hearing anything, but the proctor, that is me, is able to hear everything that is going on your end. As far as the camera is concerned, if you would like to use a fake background, that is okay. You can use a fake background if you're not comfortable with the regular background that you may have. So fake background is fine. But your camera should be on. I should be able to see you, and you should have your microphone turned on as well. Just as exam 1. Okay. During the exam, you are required to use paper and writing supplies. I recommend 1 problem per page. As I've said before, during the exam, if you have any questions, type in privately directly to me, and you as you know, I'm going to be online the entire time to answer your question right away. Write your name and page number on each page so that we have complete record of who submitted how many pages and which page goes where. The content for the exam is going to be lectures 8 through 15. So what we discussed today was lecture 16 is not going to be on the exam. The content covered until now, so communication systems, so I should say Fourier series to communication systems is going to be on the exam. In detail, I'm listing out the content here. For Fourier series, we started out talking about response of LTI systems to exponential inputs. How do you represent signals using an orthogonal set of functions? This orthogonal set that we were most interested in was the complex exponentials. How do you find Fourier series coefficients? How do you represent a periodic signal x of t as a summation of those Fourier series coefficients with their orthogonal set? What if you have a sum of periodic signals? How do you find the fundamental period and then later on find the Fourier series of that? We have done many homework problems on that as well. Next, properties of Fourier series, several of them: linearity, vertical and horizontal shifts, the time flipping property, derivative property. How do you go back after you use the derivative property? Time scaling, conjugate, using Parseval's theorem, time multiplication property, and the trigonometric Fourier series. So a bunch of Fourier series properties over here that are listed. I would highly recommend that you take a look at the homework problems again, take a look at the solutions, take a look at the back exam problems as well. So practice will help you with these Fourier series. Also make sure that you are very familiar with the reference sheets. Because I don't want you guys to spend too much time trying to look up where is what identity, right? So those basic Fourier transforms, Fourier transform properties, Fourier series properties, if you know where each one of them is, then referring to those during the exam will save you a lot of time. We also talked about response of LTI systems to cosine input. So if you have any arbitrary cosine with some amplitude, frequency, and phase, and if you pass it through an impulse, an LTI system with a given impulse response, can you find the output of that system? So all it meant was to find the frequency h of omega naught, right? So that was finding the Laplace transform of the filter and then evaluating that at the frequency of the cosine. Next major topic was Fourier transform. How did we go from Fourier series to Fourier transform? The convergence aspect, the definition of inverse Fourier transform, finding Fourier transform and inverse Fourier transform using the definitions and the tricks that we used, right? We used many tricks in order to simplify that integral, and along with those tricks we also used some properties of the Fourier transforms. Sketching magnitude and phase spectra, the basic Fourier transform, for example, rectangle and sinc and triangle and sinc squared, and multiplication in one is going to be convolution in the other. So we went through a very good discussion on time versus frequency for some standard Fourier transform. I hope you have a good understanding of those. Next, the Fourier transform properties, very similar to Fourier series properties. We have a bunch of them here: linearity, time shifting, time differentiation. One thing that we have to be careful of is we need to go back, right? Once we differentiate, we need to use the integration property to go back. Time convolution, integration property, frequency shifts property, time multiplication, a bunch of symmetry properties. Only some of them were proved in class, but you have that reference page to be able to use them to solve other complex Fourier transform problems. And then time and frequency scaling. Next, we have the duality in Fourier transform. Response of LTI system. This is going to be pretty important because this one is kind of a very a major concept here, which is to work in a specific domain, right? Working in the time domain versus in the frequency domain. How do you avoid getting into a messy mathematical simplification? How do you navigate that process? We had a very good discussion during class, and I hope you are able to apply that during the exam. Fourier transform of periodic signals. So find the Fourier series coefficients and use the table. We also proved that property during the lecture. Then we went to the last topic on the exam, which is communication systems, where we looked at amplitude modulation and demodulation. How do we use a local oscillator at the receiver to get synchronous detection? And if we wanted to do it in a cheap manner, could we use an envelope detector, which is an asynchronous demodulation, to extract the message from the carrier? And if we use asynchronous detection, then we need to have that envelope to be above 0, which means I need to add a bias, which is related to a modulation index calculation. Then on lecture 15B, I addressed these three topics: the tuned radio frequency receiver, frequency division multiplexing, and super heterodyne receiver. I recommend you to watch that video. Many of you have already done that. And if you haven't, please watch that video and ask me questions during my office hours on Wednesday or on Piazza at any time. All right, so that's essentially what I have in terms of content on exam 2. You should expect the format to be the same as exam 1, format similar to exam 1, but I will reduce the number of problems. So one common concern on exam 1 was the time aspect of things. So I'm going to make sure that even though the format is going to be similar, meaning some are going to be short answer, some are going to be long answer. I think we split it up as 5 and 5 in the previous exam. But I'm just going to try to reduce the amount of time you guys spend to answer it completely, so that it is no longer something that pulls you back. Okay, so let me stop the recording here.